Okay, so what is our host rock made of? What does it feel like at the touch? Does it feel rough? Is it smooth? Can you see the grains in the rock? You can't see the grains easily, but does it feel rough at the touch? Yes, it does. So that's what we call a very fine sandstone. It is made of sand grains that have been deposited in a deposition environment. The fact that we have fine sand tells us about the energy in the environment. The bigger the particles, the faster they settle through a water column. So to carry big particles, you need a fast flow, a lot of energy to carry big particles. The finer particles, they get transported further. Less energy in the system, they still remain in suspension because they remain longer, because they're smaller and finer. So as you move away from a coastline, you're going to have continental fluvial deposit, and then you're going to have a surf zone with a lot of energy carrying big particles. So first, in a continental environment, you're going to have things like conglomerate, a river carrying big pebbles. And then you're going to have a surf zone with large grains, like you can see in today on the beach. And as you go further, you're going to see the particles are going to become finer and finer. And that's because everything that was heavy has been transported when the system had a lot of energy, when it was a small river carrying focusing all the flow. Once it goes in the ocean, the flow becomes diffuse, the velocity drops, the particles that are heavy drop heavily. Okay? So everything that's big settles quickly. Everything that is fine goes a little bit further and further and further the finer they are, until you are at the bottom of the shelf, and basically what you deposit is the finest clay particles, okay, mudstones. So your content will change from conglomerate to coarse sand to finer and finer sand to silt and then mud, based on the energy. And what we see here is something that is still sandy, so we're not at the bottom of the shelf, but it's a very fine sandstone. So we're further away from the coast. We have already reduced the energy quite a lot. We have this fine sand, and would you say that this fine sand has been able to mold the very fine details of the ecosystem that was there? Yes, we see very small details. We see the spikes of some of these fossils. So we have a very fine dust that has molded every single detail. Okay, so a very low energy environment, a small gentle rain of very fine particles. However, you also find pebbles that are here 3 centimeters, here 1 centimeter in diameter. Some can be up to about 20. So you have big and small pebbles. These pebbles can be made of a variety of different compositions. Here you have one that's completely white. Okay, so it's just a piece of quartz that has been rounded and dropped in our... There's another one. Okay, so there's a variety of rocks that occur in our sedimentary rock as pebbles. Now that is problematic, because how do you carry a pebble in a low environment energy? If I'm saying that this is a gentle flow and gentle rain, it doesn't have the energy to carry any pebble like this. This pebble should have been dropped a lot earlier at the river mouth or even in the river. It should not be there. So how did it get here? Glacier. It has to be transported by something, and it had to be transported from the coast offshore and then dropped. And when it drops, it just sinks all the way to the bottom and hits the mud, and then, or the fine sand, and then more fine sand comes on top of it. Okay? So that's the paleo environment. We are somewhere on the shelf. We are not on the coast. We are not in a continental environment. We are in the shallow marine environment with low energy. In this shallow marine, we have a variety of creatures that are living, and I'm going to let Kathy continue on this.
So, when we look at this death assemblage, how would you describe the abundance of fossils in this location? High abundance. So, yeah, high abundance, low diversity. So it's really easy to find fossils here. Hands up if you found a bryozoa. Should be everyone. How about if you found a productive brachiopod? Again, a lot of people. Yeah. So, spiriferid brachiopods, they're pretty common.
Yeah.
So, the kinds of fossils that we find here, things like the 3 different kinds of bryozoa, at least 2 different kinds of brachiopods, 2 different kinds of mollusks, crinoid stems. There's less coral. I haven't seen any coral today. Did anyone find a coral today? Okay, so that's not as common. And I know yesterday we found a gastropod, a nice gastropod imprint. Did anyone find a gastropod today? They're not as common either. Beyond that, we don't find much else in the types of creatures. I have not had the fortune of visiting the Great Barrier Reef. Have any of you been to the Great Barrier Reef? How would you describe the assemblage of life and the diversity of life that you see there? Sorry, what was that? Dying. Okay, well, yes. Okay, not long to go, which is a tragedy, which is why I kicked myself for not going 20 years ago. But at somewhere like the Great Barrier Reef, not only is there a high abundance of life, but there's also a much higher diversity of life than what we're seeing here. So although there's lots of evidence that life was abundant here, we don't see a big range of species being successful in this environment. What kind of setting in the current world displays a similar sort of makeup where, yes, life's abundant, but there's not a huge variety of types? Does anyone know? Sorry, what was that? Yeah, cold. Exactly. So very cold environments still have abundant life, but they don't display the wide variety that we see in more tropical and subtropical environments. And that's important because that is a corroborating bit of evidence that can help us to understand the overall setting that we had in the mid-Permian when this environment was in existence. At that time, Australia was much closer to the South Pole than it is now. And towards the end of the Carboniferous, there was a great ice age which covered much of the supercontinent, Gondwana, that Australia was part of. So in the mid-Permian, we're still coming out of that great glaciation. And that's all in keeping with what we see here. So we have drop stones, which can only get transported to a mid-shelf environment by ice, whether that's sea ice or more likely glacial ice. And we have plenty of evidence of life, but not much variety of life. So all of that is in keeping with a cold climate environment at the time that this death assemblage formed. Do you think that the thing that killed this ecosystem was something catastrophic, or was it something that happened perhaps a bit more slowly?
Slowly.
Slowly. What's the evidence for that?
Because a lot of the fossils are very delicate structures, and if it was something like a volcano eruption or something catastrophic, then they would be destroyed.
Yeah, so I've even seen, some examples of bivalves where they're still attached to their other valve. So shells are still articulated, and we're getting really fine millimetre scale detail preserved well. So what killed this ecosystem was something that happened more slowly. What sort of things could have driven that? What could have made this ecosystem no longer successful? Yes, that's a possibility.
Warmer.
Yes, warming. So this diversity suggests a cold climate environment, but by the mid-Permian, climate was changing and temperatures were warming. We see in some of the fossils that we've got here internal pasts, so very fine sediment has filled up the insides of the shells and effectively sort of smothered them. So we've got a low energy environment, but sedimentation is occurring and the animals are becoming less successful. So climate change is a likely driver of the extinction of this ecosystem. Do you want to add anything?
I would add that the position of the continents in Permian time is also measured from paleomagnetic anomalies. We measure the rocks in Australia and Gondwana have solidified the paleomagnetic field at the time, and this paleomagnetic field is a function of the latitude. So we can replace the plates at different age, how far south or how far north they were. So we know that Australia was near the South Pole at the time from the record of the paleomagnetic field, and it fits what we see in the rocks of the same age. So the important thing is to learn to make clear observations and make progressively interpretations. You don't come here and deduce everything. You associate what you see here with what you obtain from various sources like paleomagnetic. Okay? First of all, you discover or you identify the rock type. You have information about the environment from the rock type, the host rock. And then you have information about the paleo environment from the fossil content. And it's all just pieces of the puzzle that you learn to put together.
It's a jigsaw puzzle, and sometimes if you're lucky you've got the box with the picture on the front, but sometimes you don't even have that. So you're collecting little bits of evidence and trying to build up a story, a picture of what was happening at that snapshot in geological time. And that can be valuable in the sense that when we look today, for instance, we're seeing climate change happening now. And so we can use our understanding of times in the past where climate change has been occurring to give us clues to what might be happening in the future. So we can see that a cold climate assemblage hasn't survived climate change well and has ended up being preserved in this death assemblage. And that is a clue that climate change can cause extinction of particular ecosystems. So we can use what we learn from the geological past to help us understand what our geological future could be.
Yeah, and geologists are always comparing what they see in the past, in the geological record, to what is currently happening somewhere. What we see in this record is not what's happening in Australia at the moment,
No.
but it's similar to what's happening in Antarctica. Climate is changing,
Yeah,
cold
and the
water
Arctic
are
in
warming up.
particular.
So we always do that, try to connect what you see in the rock record, which represents the past, to something that may be happening somewhere today. Connecting the past and the present. Okay?
All right, so we will go to Swansea and